So today, what we're going to be getting into is our gauge manifolds. The gauge manifolds are a vital, important part of a service mechanic's ability to troubleshoot the refrigeration cycle in regards to air conditioning and refrigeration systems. Without our gauges, we really cannot see what's going on internally of an air conditioning or a refrigeration system. So we have to understand not only what the gauges are reading and what they're telling us, we have to understand how to use them correctly, and we also have to know the refrigeration cycle in order to put all of the pieces together. So with the air conditioning refrigeration manifold gauges, our gauge manifolds are going to consist of two gauges. It's going to have a compound gauge, or sometimes called our low side gauge, and it's going to be blue. The blue gauge is going to be mounted on the manifold, usually on the left-hand side. The compound gauge has the ability to measure in a vacuum and pressure. The high side gauge, or sometimes better known as simply as your high side, is known for its color as being red. And that guy is going to be mounted on the right side of the manifold. A standard manifold gauge is going to have those two gauges and at least two hand valves on there. So here's your gauges. You have our blue gauge. We have our red gauge. Our blue gauge has the ability to measure above and below atmospheric pressure, or above pressure and in a vacuum. Our blue area is what's measuring our pressure. Okay, usually the blue gauge in some cases will go up to about 350 psi, and then you'll notice that it has this little area in here that says retard, and it goes from 350 up to 500. Okay, now what does that mean? It just simply means that the gauge just does not have any more room to fit all of our nice little hash marks. So it's telling us that if you ever have a pressure that is this high, you seriously got a major problem, first off. But it's just telling you that the pressure is somewhere in between 350 and 500 psi. In my entire career of doing this for over 20-something years, I have never once seen a low side pressure gauge get that high, but it's there. The green portion of our compound gauge, this guy down here, is measuring our vacuum, which is measured in inches of water column. I'm sorry, not inches of water column, inches of mercury. Okay? The other areas that we want to see on our manifold gauges is actually in our standard gauges actually has the ability to measure the pressure of at least 3 different refrigerants. So in this case, we have R22, which is in green. Okay, so this green area is actually measuring temperature for R22. Okay, so we can actually take this type of refrigerant gauge and take our pressures and convert it to temperature. We can also do that with 410A, which is this black set of numbers. And then this here is 404A, which is orange. So these types of gauges usually has the ability to at least be used on 3 separate types of refrigerants. The same thing kind of applies for our red gauge. The red area measures all of our pressure, and it goes from usually 0 to about 800 psi. The green area is our temperatures for R22. Black is 410A, and in this case, this is 407C. Okay, so that's really what our gauges look like up close. The gauge manifolds allows the service technician to check the operating pressures of both the low side and high sides at the same time. So when we are putting on our gauges, we are going to be putting on the gauges on both the low and the high side to see what's going on both sides of those systems, to tell us whether or not a system is working the way it's supposed to. When we are looking at those gauges are reading in pounds per square inch. The gauge is reading, reads the pressure under each gauge from the hose that is actually connected to it, without opening the valves. That is one thing that is extremely important when we are taking pressure readings. The two hand valves that we have on our manifold gauge, those valves are closed at all times, unless we are adding or removing refrigerant, or doing a pressure test, or doing an evacuation. Okay? Our gauges do allow us to do some additional stuff, such as adding oil, refrigerant oil to a system. It also has us bypass a compressor, which I'm going to be honest with you, I have never done. Bypassing a compressor. It also allows us to perform other service operations such as recovery, evacuation, pressure testing, stuff like that. So here is our manifold gauge put all together. Now the manifold may not look exactly like you see here, but it will have at least two hand valves, one for our low side, one for our high side. You will have your high side gauge, which is going to be red. It's going to have our compound gauge, which is going to be blue. You're also going to have three hoses, a blue hose, which is used to measure our low side of our system. We're going to have a yellow hose, which is all of our service work, which is going to be used to connect our refrigerant cylinders, recovery machines, vacuum pumps, nitrogen cylinders, stuff like that. And then you will have your red gauge. The red gauge is what measures our high side of the system. The low pressure gauge, or the blue hose and the blue gauge, is what measures the pressure of the whole side of the low point of the system. The low side of the system is from the metering device all the way back to the compressor. So the blue gauge in our blue hose is measuring from the outlet of the metering device through the evaporator and all the way back to the compressor on the suction line. The high side gauge in the high side hose, red hose, is measuring from the compressor through the condenser all the way up to the metering device. That's really important to remember. What are my gauges reading? The blue hose measures the low side of the system, from the metering device all the way to the compressor. The high side gauge reads from the compressor all the way to the metering device. Manufacturers color code the low and high sides simply for simplicity. Okay, we like to use a lot of association in air conditioning. Blue means low pressure, red means high pressure. So we're going to put those hoses where they need to be on the system. The hand valves on the side of the manifolds separate the gauge pressure chambers from the manifold's center chamber. The center chamber is where the yellow hose is actually connected to. The center chamber is located between the low and high side of the gauge manifold. The yellow hose is connected to the center port, and that is where we're doing all of our service work. The yellow hose is our service hose. We're going to use that to connect refrigerant cylinders, recovery machines, vacuum pumps, nitrogen cylinders. That's the hose that's going to be used for all that stuff. Some gauge manifolds have a sight glass on them that can be used to view the flow of liquid through the center chamber, so you can actually see refrigerant going through and into a a system for either recovery or charging. It's just a nice little feature. Not every manifold gauge set will have it. You may also get a set of digital gauges now, and these types of gauges are very, very expensive. I just recently picked up a set of field piece digital manifold gauge set. This guy has the ability of having at least 30 different refrigerants already programmed into it. So all I have to do is just select the refrigerant that I'm working with, and it converts my pressures and temperatures already for me. I have the ability to connect the manifold to my phone, where I can perform live action stuff. So I can leave my gauges outside, let the system run. I can go inside and work on whatever it is that I'm working on, and I can honestly monitor the pressures as I'm doing things. Some other gauges do have the ability to have different types of temperature sensing type equipment on there, such as like thermocouples or computer software. So it all depends on how much money you want to spend on them. But there is a lot of technology out there to help us make our jobs a lot easier. The manifold construction is also important when it comes to working with these things. You have to understand that these tools are delicate. You do not want to damage them. You do not want to drop them. You do not want to over tighten the hand valves on them, because inside there are little rubber O-rings. Those O-rings is what prevents the refrigerant from leaking out around the valve stem. And when the valve is turned counterclockwise, the valve plug moves outward from the seat, opening a passage to the center port from one of your side ports. So if I was to over tighten my hand valves, I'm going to damage those O-rings, and now I have leaky valves. Some manifold gauge sets are serviceable, where you can kind of take it apart and put new O-rings in, but some of them are not. So you need to be very cautious when it comes to handling your manifold gauge sets. Purging your gauges in your hoses. We want to make sure that our hoses and tools are clean at all times. We do not want to be dragging our hoses through the dirt, through the grass, through puddles. We don't want to step on them. Okay, we want to make sure that our hoses are dry and free of contaminants as much as possible. So in order to do that, we need to purge the gauges and our hoses to free our tools from any sort of non-condensables, air, debris, dirt, stuff like that. Because if we don't do this, we run the risk of introducing those types of foreign material into an air conditioning or refrigeration system. That's not a good thing. Non-condensables, moisture, dirt can be detrimental to an air conditioning or refrigeration system. So we have to make sure that we don't do that. And the only way we are able to prevent that from happening is by purging the gauges and our hoses. Okay, purging refers to the process of removing unwanted vapors, dirt, and moisture from your refrigerant hoses that connect the gauge manifold to the refrigeration system and releasing the contents into the atmosphere. Purging of refrigerant hoses uses refrigerant as a purging agent. When performing a purge, releasing a little refrigerant as possible should be done to reduce the impact of the environment. Using quick connect fittings greatly reduces the amount of refrigerant that is released. Quick connect fittings are spring-loaded brass fittings which seal off refrigerant inside each hose. Older gauge sets can be retrofitted with quick connect fittings. EPA now requires refrigerant gauges to have quick connect fittings on there. If you have an older style set of hoses that don't have it, you can simply purchase them online. You can go to Amazon, you can go to eBay, and just simply type in quick connect refrigerant fittings, and they pop up. You know, they're pretty much like a dime a dozen now. Purchase a set, put them on. Steps for purging your manifolds and your hoses. To purge the gauge manifold and refrigerant service lines, you have to first begin with making sure that the refrigerant cylinder and your gauge manifold valves are closed. Service valves should be backseated to ensure they are completely closed. After doing so, you are going to now connect your yellow hose, which is your service line of the manifold gauge, to a refrigerant cylinder containing the same refrigerant used in the system. You're going to remove the caps from the system service port and loosely connect the gauge manifold's low side and high side service lines for purging. After that, you are now going to open the low and high side valves on the gauge manifold, briefly crack open the cylinder valve on the refrigerant tank to flush the gauge manifold and service lines of any refrigerant. Okay, any moisture or debris that is in the line should be forced out of the loose connections at the service port. Close the cylinder valve and tighten the refrigerant, the service line fittings at the service ports. The service valves can now be opened without fear of contaminating the system. So when we are hooking up our refrigerant gauges, this is typically what we're going to see. We're going to have our refrigerant cylinder, which is going to be connected by our yellow hose. Okay, in this case, this is actually a recovery machine or a recovery tank. So in this picture, they're doing a recovery. So we have our high side hose, which is connected to our high side of our system, which, remember, is from the compressor all the way to the metering device. And then you have your low side gauge, which is connected to the low side of the system, which is from the metering device back to the compressor. The operation of your gauge manifold consists of opening and closing the high side or low side hand valves. So when we are doing simple pressure readings, we need to make sure that the hand valves are closed, and by closing them, we close off our low side ports and our high side ports from our center port. If we are doing an evacuation or a pressure test or anything like that, we are now able to open both sides to allow our nitrogen and our vacuum pump do whatever it is that we want it to do. We can now do either a vapor charging. If we're doing that, we're going to open up the low side valve, because we need to understand that when we do a vapor charge, we are charging the refrigerant with simply pure refrigerant vapor, which is going to be sucked in through the system, through the low side of the system. Or we can do a liquid charge, which would be through the high side of the system. Connecting our manifold gauges, it all depends on the type of system design that we are dealing with. Most of our residential split systems, you will have a suction service port and a discharge service port, or even a liquid line service port. Some other types of systems may only have a suction service port adapter mounted on the compressor. Some may have no service valves at all, but have a process tube to connect a refrigerant line to, and then some may not have anything at all. So you may see stuff like this. So you may see a service valve and a discharge line valve that you can connect your hoses to. You may see a valve adapter, which is going to be connected right to the top of a compressor. You may see a process tube like this on a compressor, or you may actually have to install a piercing valve on a system that does not have any sort of access fittings whatsoever. A common one that will have something like that is your window units. They typically do not have a service port or anything on there, so in order to get access to the refrigerant system itself, you have to put in a piercing valve. Refrigerant system analyzers. These instruments are a combination of your gauge manifold, temperature sensors, and other sensing elements all in one package. They can also include digital connectivity and some other troubleshooting capabilities. Refrigerant system analyzers are used to measure system variables such as your pressures and temperatures. It can also help to determine whether or not the system is actually operating at its peak performance. It can also help measure superheat and subcooling to indicate whether a system charge is actually correct. They can also have data logging capabilities to allow a technician to keep track of a system operation over a period of time. You may something like this, which is a nice set to have. This case here is actually a 4-valve manifold set. You'll have your blue gauge to measure your low side of your system. You'll actually have a larger yellow hose connected to it, which is used for evacuation. You will have another yellow hose, which is used for simple service such as charging and pressure testing. And then you'll have your red hose, which is used to measure your high side system pressures. Instead of actually having gauges, it actually will have a nice little display, which will give you a digital readout of your system pressures. Using the clamps here, you actually can use to take temperature readings of your refrigerant lines, which will actually convert onto the screen and can actually give you your superheat and subcooling readings. This down here, this type of tool here will actually be used to measure